Hello students, welcome to Infinity Learn by Sri Chaitanya. I'm your tutor Akshay and today we are going to see the paper solution of 23rd Jan Shift 2 paper. Okay, so let's start the session and look at here. Question is asking the internal energy of a monoatomic gas. First information is monoatomic gas, that means degree of freedom 3. Okay, gas is 3 nRT. So internal energy is given, that is 3 nRT. Okay, 1 mole, number of moles 1. 1 mole of helium is kept in a cylinder having internal cross section area of 17 centimeter square. So let's draw the diagram. So if this is the cylinder and let's say this is the piston, so this cross sectional area is given 17 centimeter square. Okay, cross sectional area is 17 centimeter square and fitted with a light movable frictionless piston. The gas is heated slowly by supplying 120 joule of heat. Let's say you are supplying 126 joules of heat. So it will change its internal energy and some part of this given energy will do the work, okay, in the form of expansion. Now if the temperature rises by 4 degrees centigrade, so delta T is 4, okay, 4 degrees centigrade, then the piston will move centimeter atmospheric pressure. Okay, so the movement of piston, let's say piston moves delta X. Okay, so now what do we know about this? That Q is delta U plus W, right? So value of Q is given, that is 126 joules. Okay, and what do we need? This delta X. So could I say that delta V would be what? Area into delta X. Yes sir, we can say that area into delta X will give us the delta V, change in volume. Let's apply this. So Q is 126 joules. Okay, then 126 delta U. So delta U will be what? 3 nR delta T, right? So delta U will be what? 3, number of moles 1, R is 8.314. Okay, 8.314, that's not a point. So wait, so R is given 314 and work, so work will be what? P delta V, or I would write it P delta V is what? A delta X. Okay, now pressure is given or not? So atmospheric pressure is given, that is 10 raised to 5 Pascal. Area is given, so area would be what? 17 centimeter square. So from here P and area is 17 centimeter square, means 10 raised to minus 4, that is meter square, because all the values are in SI units. So I need to put this area also in SI unit. Then also that's the only case I'm going to get delta X in meters. Then our answer is in centimeters. So again I'm gonna convert that meter into centimeters. Okay, so P and this is what? Delta V, that would be equal to 126 minus and 3 into 8.314, right? Okay, 3 nR delta T, sorry. So delta T means 3 into 8.314 into delta T is 4. Okay, so now could you tell me the value for this? Okay, so from here when you will calculate this, you will get the value of delta x, and here we have delta x as well, right? So delta x value is going to be 0.155 meters. Now 0.155 meters means 15.5 centimeters. Okay, question is very easy. First of all, given is that internal energy, expression for internal energy is 3 nRT. If you are changing temperature by 4 degrees centigrade, then change in internal energy would be nr delta t, 3 nr delta t. Okay, put those values, and you know q, this is given, it equals some heat will be used in the internal energy, that will change internal energy, and some amount of heat will do the work. So given heat q equals delta u plus w. When you will solve this equation, you will get the value for delta x, and pressure value is also given, that is 10 raised to 5 pascals. Okay, simple. Now we are going to move into the question number 2. Question number 2 is a body of mass 14 kilograms. Okay, a body of mass 15 kilograms initially at rest explodes in and break into 3 fragments of masses in the ratio of 2:2:3. The 2 pieces of equal masses fly off perpendicular to each other. Equal masses, that means this is 2 kilogram. Okay, let's say 2 unit, and this one is another 2u, with a speed of 18 meter per second. First of all, let's say speed is v for both, because it is given that both are equal. So the velocity of the heavier fragment, so if they have same amount of momentum in this side and that side, so the resultant will be at 45-degree angle. So resultant will be somewhere here. V, this would be root 2v. So could I say that m root 2v, and this m mass is how much? 2 unit. So I am gonna put it 2 units. 2 into root 2v will be equal to this momentum, and what I am applying here, the conservation of linear momentum. Okay, so it's 3 unit, and velocity, let's say v dash. Now v dash would be what? 2 root 2 by 3 into v, and v was given 18 meter per second. 3 is 6 the 6 2 the 12, so 12 root 2 meter per second. Simple. Option number A. See, questions are really easy. We had any object that explodes into 3 parts. One part is going upwards, another one is going in this direction, because it is mentioned in the question that those both are perpendicular to each other. That means what? They are having net momentum at 45-degree angle. So in same opposite direction, that 3 kg or 3 unit mass will move with some velocity, and this momentum should be equal to this momentum. That's the case. Okay, that's what we did here, and answer is 12 root 2. Good. Now question number 3. A block is sliding down on an inclined plane. So first of all, let's draw that inclined plane. So we have this object, and this is moving downwards. Okay, slope of theta. So slope is theta. Instant t equals 0, this block is given an upward momentum. Now you gave it one momentum. Momentum means mu, means you are providing some velocity in upwards direction. Okay, so that it starts moving up on the inclined surface with velocity u. The distance as travelled by the block before its velocity becomes 0. Let's say velocity becomes 0 here. So we need to find s. This is s displacement. You know, mg is applied downwards. This is mg downwards. And let's draw perpendicular, because in this direction we have normal force. So could I say that if this is theta, this would be 90 minus theta, and this angle would be again theta. So this is mg cos theta, and this would be what? Mg sin theta. And friction is not mentioned in the question. If friction is not there, then I'm gonna count only mg sin theta. So we have acceleration downwards, and that acceleration is what? Force by mass. That means g sin theta. If that's the acceleration, now question is easy. See what I'm doing here. Let's say initial velocity u, that is given, final velocity v, that is 0, because we need this maximum distance, right? So here velocity will be 0. So I'm doing that v square, that means 0 square equals u square minus sign. Why? Because this is the case of retardation. In the case of acceleration we take plus sign, in the case of retardation we take minus sign, because velocity and acceleration are in opposite directions. Okay, minus 2a, acceleration is g sin theta into s. From here s would be what? U square upon 2g sin theta. So u square by 2g. Okay, so answer would be u square by 2g sin theta. That's the bonus, because NTA released the paper and none of the options is matching with the answer, and answer would be what? U square by 2g sin theta. Okay, guys, in question number 4 we have the current passing through a conducting loop in the form of equilateral triangle of side 4√3 centimeter. So as question is asking, first of all let's draw a diagram. So this is what? Equilateral triangle. Okay, side is 4√3. Okay, and centimeter. If I draw a perpendicular on this, then can I say that this distance is 2√3? Simple, half of 4√3. And by Pythagoras and by Pythagoras theorem, could I say that this height is 6 centimeter? All the values are in centimeters. And then let's read the question. Of side 4√3 centimeter is 2 ampere. Current I is 2 ampere in the loop. Okay. The magnetic field at its centroid is alpha. This is the magnetic field at centroid. This is centroid. So you guys are aware that centroid have 2:1 ratio on this perpendicular. So if total is 6 centimeters, then this would be how much? 4 centimeter and this is 2 centimeter. Now that was the ratio 2:1. So let me remove that, and this is 2 centimeters. Similarly, this distance is also 2 centimeter. This distance is also 2 centimeter. Correct? Now let me tell you, if I consider that this is the direction of current, then magnetic field direction here, in this wire in the same direction, and in this wire as well, direction of magnetic field is outside the plane. So total magnetic field would be 3 times of, for one wire, that is how much? Mu naught I by 4 pi r and sine theta 1 plus sine theta 2. Okay sir. Now 3 mu naught upon 4 pi 10 raised to minus 7. I current is given 2 ampere. R is 2 centimeters. That means 2 into 10 raised to minus 2 centimeters. Then sine theta 1. So let's draw theta 1 and theta 2. If this is 60, this is 30. If this is 30, this is 90, then theta 1 is 60. Similarly, theta 2 is also 60. So sine 60 means root 3 by 2 plus root 3 by 2. Okay. Now we can cancel 2. Okay. Something else, root 3 by 2 plus root 3 by 2, root 3. So 3 root 3 into 10 raised to minus 2 minus, okay, minus 7 minus 2, 10 raised to minus 5 Tesla, and that was given as alpha into 10 raised to minus 5 Tesla. So value of alpha is 3 root 3. I hope you guys understood. Yes, simple. Okay, now let's move to the next question. In next question, we have a paratrooper jumps from an aeroplane and opens a parachute after 2 seconds. So he jumped, let's say he jumped from here, and after 2 seconds, somewhere here, he opened its parachute. Okay. So now, till now, in 2 seconds, we know if initial velocity is 0, here velocity would be what? U plus at. Acceleration is what? Acceleration due to gravity 10. So 10 into 2, 20 meter per second. Okay. And this displacement S1 will be what? Ut, initial velocity 0, half at square. Half into G. G is 10 into T square. 2 into 2. So 20 meters. So could I say that S1 is 20 meter. Now S1 is 20 meter. Then after this its deceleration or retardation is 3 meter per second square. So acceleration is minus 3 meter per second square. Okay. And at 10 meter height from ground, let's say here 10 meter from ground, its velocity is 5 meter per second. Here velocity is 5 meter per second. So here to here, what will be the displacement? This is S2 displacement. How would you write that displacement? Here velocity was 20, there 5. So could I say 5 square equals 20 square minus 2a. But now here acceleration is what? 3. This is the case of retardation. Into 3 S2. Let's say this is S2 displacement. So that would be 6 S2 equals 400 minus 25. So S2 would be what? 375 upon 6. 3 1 ja 3, 3 2 ja 6, 3 5 ja 15. Okay. And here we have 2. And that gives us 2 6 ja, 2 2 ja, 2 5 ja, 62.5 meter. This displacement is 62.5 meter. Okay. And last, that is 10 meter. Sum of S1, S2 and S3 would be the total height. So S1 is 20 meters, S2 is 62.5 meters, S3 is 10 meters. Sum would be the 92.5 meters. Is it okay? Okay. Good. Now, in the next question, we have two short dipoles AB. So this is A dipole and this is B dipole. Okay. Now A having charges plus minus 2 microcoulomb. So its charge is 2 microcoulomb and its charge is 4 microcoulombs. Okay. And length is 1 centimeter for both the dipoles. Now this distance is 80 centimeter. So this distance is 40 centimeter. This is also 40 centimeter. Okay. With their centers 80 centimeter apart as shown in the figure, the electric field at a point B equidistance point sorry from the centers of both dipoles. So due to this dipole, you know that direction of magnetic field will be in this direction. Yes or no? And due to this dipole, direction of magnetic field is this. Let's say this is BA vector, this is BB vector, BB vector. Okay. So BA and BB, total B net vector would be what? BA vector plus BB vector. Okay. Now let's say this is positive x direction and this is minus y direction. Plus I cap minus j cap. Whatever you want you can take. BA. So BA is due to this 2 kp by r cube. 2 kp by r cube. Okay. And I cap. This is minus j cap. So minus kp by r cube. Right? J cap. Now see, k value is same. Right? K value is same. P is what? So let me take common kp by r cube. Kp by r cube and okay, P is not same. K and R same. So K is 9 into 10 raised to 9. First of all, K is common. K by R cube. R distance is 40 centimeter means 0.4 meters. Right? So cube of 0.4 meters. Now we have 2P. 2PA and this is PB. So 2PA. PA. So PA will be what? 2PA. So P will be 2 into L displacement. 2 into 1 centimeter. 1 centimeter means 10 raised to minus 2. Sorry. Okay. This is in I cap. Minus again. Here we have PB only. PB is what? 4 into 1. 4 into 1. 1 means 10 raised to minus 2 centimeters. J cap. And one more thing we have, that is multiply 10 raised to minus 6. Cause charge is in microcoulombs. Okay. Now 9 into 10 raised to 9 upon, let's say, okay, let's do one thing, 4 by 10 into 4 by 10 into 4 by 10. So 64 into 1000. Then 10 raised to minus 6. Let's take 10 raised to minus 2 common. 10 raised to minus 2. 2 to the 4 I cap. 4 I cap minus 4 j cap. Okay. So first of all, let's calculate this value. So this value would be what? This value would be 9 into 10 raised to 9000. Okay. 10 raised to minus 6 minus 2 minus 8. So we got only one power. Then we have 9, 1, 2, 3, 4. 9 by 64 into 10 raised to 4. And 4 I cap minus 4 j cap. That means what? That would be 4 root 2. 4 root 2, right? Now 16. 9 by 16 root 2. 9 by 16 root 2 into 10 raised to 4. Option B. Did you understand? Concept is easy. If you know the concept, questions are easy. Now next is two charges 7 microcoulomb and minus 2 microcoulomb are placed at minus 9 and plus 9. Okay. Let's say this is minus 9 comma 0 comma 0 centimeters and this point is plus 9 comma 0 comma 0 point. Here we have 7 microcoulombs, right? Here we had 7 microcoulombs and there we have minus 2 microcoulombs. Okay. So Cm respectively in an external field E. Electric field is given, that is A by R square into R cap. Okay. So now where A is 9 into 10 raised to 5. So let's write that 9 into 10 raised to 5 upon R square and in R cap direction. So first of all, what can you do here? If you have E, can I say that V will be, and V is what? V is not a vector quantity. So V would be E by R. Yes or no? V would be what? E by R. Now Q1V plus Q2V plus KQ1 Q2 by R. That would be the total energy, total potential energy. But that's a lengthy method. If you have this point here, could I write it like this? 9 into 10 raised to 9 into 10 raised to minus 4 upon R square. That is what? That is KQ by R square and R cap direction. That means what? 8 0 comma 0, 8 0 comma 0 comma 0. We had one more charge and that charge was 10 raised to minus 4 or 100 microcoulombs. Now that is very easy. Now you can do it very easily. How? Total energy would be what? K Q1 Q2 by R. So first of all, K is common. Q1 Q2. Q1 Q2 7 into 100. 700. Okay. And micro will take that in the out of the bracket. Okay. 700. Then 100 minus 2. So minus 200 and minus 14. Okay, upon 700 upon this r distance is 9 centimeter, right? Yeah. So 9 square, not square, only 9 centimeter. So I'm going to take that centimeter 10 raised to minus 2 here. Okay, 9, 200 upon, so that is 7, 2. So that is 18 centimeter. And in this case, okay, here also we have only 9 centimeter. This is also 9 centimeter, and here we have 18 centimeters. And Q1, Q2, both the charges have micro. So 10 raised to minus 6, minus 12. Now let's do it. K is 9 into 10 raised to 9 upon 10 raised to minus 2. Let's take 9 common. And here we had 10 raised to minus 12. And in the bracket we have 700 and minus 200 and minus 7. Okay, so now 10 raised to minus 2 minus 12. So right here 1 0. So this 10 multiply with 10. 10 raised to 10 minus 12 minus 2. So you can cancel all these values. Now you are left with 9 by 90. That means 1 by 10. 1 by 10. Okay. And 700 minus 200 is 500. And 500 minus 7, 493, right? 493. And that would be 49.3 joules, right? So that's how you can do it easily. Otherwise, by this method also you will get answer 100%. Okay. Then the next question is asking a bead P sliding on a frictionless semicircular string ACB. Okay, ACB, and it is 8 point S. You know, this is the question from IIT 1993. Okay, so I know you guys know the answer already. What would be the answer? But that's the best question for clearing doubts. Question is asking that this TP would be greater or TQ would be greater. That means this Q will take more time or P will take more time. And you know Q is going to take more time. Why? Because here it started with V velocity and here its H component is moving with V velocity on 45. So that 45 angle will be somewhere here with V velocity. But here we have some more velocity. This is 45 angle. This is also 45 angle. In this direction also we have V velocity. But at the bottom completely velocity would be root 2V. And it would be V again here. V and V. Are yes or no? V and V. So throughout this total displacement is AB in both the cases. Total displacement is AB, but in ACB case V, let's say V is average velocity. Average velocity in ACB is greater than V in AB. That means what, sir? That means its average will be more. Okay. So answer would be option number 3. So that is going to take more time because its velocity is more in X direction. Okay. Okay. So now a parallel plate capacitor with plate separation 5 mm is charged with a battery on introducing a mica sheet of 2 millimeter and maintaining the connections of the plates with the terminals of the battery, it is found that it draws 25% more charge. Means its capacitance is, if initial capacitance is C naught, so now capacitance is 25% more, that means 5 by 4 of C naught. Okay, that's what I'm going to do here. So initially separation was 5 centimeter, now 2 centimeter is filled with a dielectric and dielectric constant. Okay, we need to calculate that constant K. Okay, so now initial capacitance C naught was A epsilon naught by D 5, but now that is in series. So in series C equivalent is C1 C2 by C1 plus C2, you know. Now C equivalent, so C1 is what? This is C1 capacitance, C2 capacitance. So let me write C1. C1 is A K epsilon naught by D 2, and C2 is A epsilon naught by D is 3. So now we could do one thing, that let's write this A epsilon naught as x. So this is K x by 2, or let's say A epsilon is 1, then calculations would be more easy. Okay, let's do it, sir. So let me write it K by 2. This is K by 2, and here we have 1 by 3, and here we have 1 by 5. So now C dash is what? C dash is 5 by 4 of C naught. So 5 by 4 of 1 by 5. So that is 1 by 4. Okay, 1 by 4. C dash is 1 by 4 equals C1 C2. C1 C2 is K by 2 into 1 by 3 upon C1 plus C2, K by 2 plus 1 by 3. Okay, cross multiplication. In cross multiplication we got the value that 1 by 4 K by 2 plus 1 by 3 equals K by 6, and here we got K by 8, 4 to the 8 plus 1 by 12 equals K by 6. Then value would be what? 1 by, okay, 3 2s are 6, no, 2 3s are 6, 2 6s are 2 4s are. So K by 3 minus K by 4 equals 1 by 6. Now 4K minus 3K upon 12 equals 1 by 6. 2. So 4K minus 3K is K equals 2. See, simple. So answer would be option number D. Okay, any mistake, any doubt? Okay, so then we have question number 10. To compare electromotive force EMF of two cells using potentiometer, the balancing lengths obtains 200 centimeter and 150 centimeter. So let's say EMF for first is 200 centimeter into, let's say, any constant, lambda 1 constant. E2 is 150 into lambda 2 constant. Okay, the last Okay, the least count of scale is 1 centimeter. Okay, so that's very simple, that E is proportional to L. Okay, E is what? Proportional to L. Now the percentage error in the ratio of EMFs. So if you want ratio in E1 by E2, so that would be L1 by L2. Okay, this constant is same. Constant is same. Now if you want error, so that error would be error. I told you maximum error will be added in the case of multiplication and in the division. So that would be delta L1 by L1 plus delta L2 by L2. Okay. Now least count is given 1 centimeter. So 1 upon L1 is 200 centimeters plus 1 centimeter in 150 centimeters. Okay. Now that value would be what? The percentage error. So if you want percent error, right? So percent error multiply with 100. So we got the value. Okay, first of all cancel out 0, then 5 2s are 5 3s are 5 4s are. Now 1 by 4 plus 1 by 3 is 4 plus 3 7, right? 4 plus 3 7 by 12 into 2 by 6. So 7 by 6, or answer would be 1.166. 1.166. Okay, did we make any mistake? 1.166. Okay, this is bonus. This question is bonus. Okay students, so in this question we have an air bubble of volume 2.9 centimeter cube. So let's assume this is air bubble and its volume is 2.9 centimeter cube. Okay, rises from the bottom of a swimming pool. This is the bottom of swimming pool. It rised from there. Okay, 5 meter deep. 5 meter deep. Okay, at the bottom of the pool water temperature is 17 degrees centigrade. 17 degrees centigrade means 290 kelvins. Yes, the volume of the bubble when it reaches the surface where the water temperature is 27 degrees centigrade. That means here temperature is sorry. So their temperature is 300 kelvins. Okay, then where the water temperature is 27 degrees centigrade. Okay, we need volume here. What would be the volume here? So when this bubble was here, its initial volume is 2.9 centimeter cube. Okay, and final value also we need in cube, centimeter cube. No issue. G is given 10. Density of water is 10 raised to 3 kilogram per meter cube is given, and 1 atm is the pressure, 10 raised to 5 Pascal. So here if I say number of moles n, then here also number of moles are n. Simple. If initially number of moles are n, then final also number of moles n. So could I say that P1 V1 upon T1 will be equal to P2 V2 upon T2? Simple. I applied PV equals nRT. Now what could we do here? So let's say atmospheric pressure is P naught. So now this pressure is how much? This is P naught plus rho GH. Okay, So P naught plus rho GH. P naught is 10 raised to 5 pascals. Rho is 10 raised to 3. Now this value is in SI. This is also in SI. G10, height is 5 meter. Okay. So that is how much? That is 5 and 1, 2, 3, 4. Okay, 50,000. Rho GH is 50,000. And P naught is how much? 10 raised to 5 or 100,000. Okay, 100,000 pascals. So we said that here pressure is 150,000 pascal, and here pressure is how much? The pressure equal to P naught, right? An air bubble of volume 2.9, bottom swimming pool of 5 meter deep. At the bottom of the pool, water temperature is this. Okay. So P1 150,000. Okay. Volume V1. So V1 and V2 both are in centimeter cube. So we can put that 2.9 upon T1. T1 is 290 Kelvin. P2 pressure only 100,000. And V, that's what we need to know. We need to find, and temperature is 300 Kelvin. 2 zeros. Okay. Now 1, 2, 3 zeros. 1, 2, 3 zeros. One more zero. Then okay. Okay. Now 29. So we are left with 15 by 10, right? 15 by 10, yes or no? Yeah, 15 by 10, and everything is cancelled out now. And there we have V by 3. So 45 by 10 is V volume. So final volume is 4.5 centimeter cube. I hope you understood. So, question is very simple. Initially we had pressure that was 150,000 pascal. Volume were 2.9 centimeter cube. And why I am taking only in centimeter cube? Because final value is also going to be in centimeter cube. And if those things are in an equation where we are equating both the things, then we can take. Okay. So answer would be 4.5 centimeter cube. Then question number 12 is, so now the question number 12 is, which of the following pair of nuclei are isobars of the element? Now which are the isobars? So where you have same weight. So 1H3 and 2He3. Simple question. Let's move to the next question. Well, if question is simple, we are not going to waste our time. So basically this is what? This is AND gate. This is OR gate. So 1 by 1, let's put it 0, 0. So N, M, 0, 0. When you put 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, okay, 0, 0, 1. So output would be 1. Then put 0, 1. There 0, here 1. 0, 1. So 0 plus 1, 1. But 1 into 0, again 0, 0, 1. So 1. Then put 0, 0, 0, 1, 1, 0. 1, 0. 1, okay, 1 and 1, 0. So 1, 0, 1. 1, 1, 1 or 0. Output would be 0. Then 1, 1. 1 and 1. So 1, 1, 1. 1, 1, 0. So which one will be the correct one? 001, 001, 011, 110. So option number 1. Okay. Did you understand? This is also a simple question. We are not going to waste our time in this question. Okay. This is a good question. 1 mole of an diatomic gas. Diatomic gas, degree of freedom 5. The first thought which comes in my mind when I see a diatomic gas, that is degree of freedom is 5. Number of moles 1. Expands from volume V to 2V. Volume from V to 2V. V to 2V isothermally. Isothermally means temperature is constant. Okay. And you know, for isothermal process work is what? nRT by V dV integration, and that is from V1 to V2. So nRT ln V2 by V1, that is 2V by V. So ln 2. For this work is nRT ln 2. Then isothermally at a temperature 27 degree, and this is happening at temperature 27 degree centigrade, means 300 Kelvin. Okay. And does W joule of work. Okay. So that is W joule of work. If the gas undergoes same magnitude of expansion, means V to 2V. Okay. Adiabatically from 27 degrees centigrade. Okay. So in isothermal process, you know, delta U is 0. So basically this is Q equals W. But in adiabatic process, Q is 0, heat transfer 0, adiabatic process. So W is minus delta U or minus n CV delta T or minus NFR by 2 delta T. Now delta T should be negative. So we could remove this sign. Okay. So I would write that NFR by 2 T, and final temperature should be lesser than the initial temperature. Okay. We know the initial temperature. If you know the initial temperature, that is 300 kelvins. So put that 300 kelvins here. So that would be, initial temperature will be greater because delta T should be negative. Delta T should be negative. So can I say that T minus, or T is given, and T is how much? T is 300 kelvins. 300 kelvins minus final temperature. So this is what? N CV delta T equals to this work, same amount of work, nRT. So N R T is given 300 Kelvin ln 2. So cancel out nR. F is 5. So 5 by 2. 5 by 2. What do we need? The final temperature, right? So we can do one thing, that 300 minus T would be what? 2 by 5, right? Yeah. 2 by 5 of 300 into ln 2, and this would be 60. 60 to the 120. ln 2 is given or not? Yeah, ln 2 is given, that is 0.693. Okay. So temperature would be what? Final temperature would be 300 minus 120 into 0.693. Okay. That would be 300 minus 120 into 0.693. Okay. So that final temperature value will be almost 216 Kelvin. Okay, when you will solve it, final temperature will be almost 216 Kelvin. Now could you change this Kelvin into the degree Celsius? Because we need in degree Celsius. So 273 minus 216, almost 56 will be the answer. Okay, simple. Now let's see. Okay, let's do the question number 15. In question number 15, question is asking that we have a prism. This is prism. Okay, and prism angle is 75 degree. Okay, now we need to find the angle I at which we incident a ray, so we could see total internal reflection. And by the way, here we have a coating of mu 2 equals 1.5. Okay sir, see, simple. Now we can do one thing, that here if this is 90 angle, then this is what? Critical angle. Let's say this is theta. So could I say that this theta, so mu 1 is what? Its mu is how much? Mu 1 is root 3, right? Now apply mu 1 sin theta equals mu 2 sin 90. Why sin 90? Because this is case of TIR. Sin 90 is 1. Okay, mu 1 is root 3. Root 3 sin theta equals mu 2 is, let's say 3 by 2, right? 1.5 is 3 by 2. So can I cancel it with root 3? So sin theta is root 3 by 2. That means what? Theta equals 60 degree. Okay, now I got the value of theta, or let me erase it, and this angle is 60. Okay, if this angle is 60, then this angle is 30. Okay sir. If this angle is 75, this is 30. 75 plus 30 is 105. So this angle would be what? This angle would be 75 degree, right? 75 degree. And this complete angle is 90. So this R angle is what? R angle is 15 degree. Are yes or no? Again same, mu 1 sin I. Mu 1 is 1 sin I equals mu 2. Mu 2 is root 3 sin R. Sin R is 15 degree. Okay. Then what do we need? We need I angle. So sin I equals root 3. Sin 15 is given. Yes. 0.25 or 1 by 4. Root 3 by 4. So sin I is root 3 by 4, and root 3 is 1.732. 1.732 by 4. When you divide it, it gets 4 4 is 16 and 4 3 is 12. Okay, so 0.43. That means what? I angle. So sin, that means I angle is 25 degree. But now try to understand the question. If you found that I is 25, you will tick this answer. No, this I should be less than 25. Why less than 25? Now look at here. If this I is greater than 25. Greater than 25 means somewhere here. If this is somewhere here, so let me take another color. Let's say I is some, okay, this is I, more than 25. So refracted ray will be somewhere here. So this angle will be less than critical angle and it will pass through the prism. That means what? This I angle should be less than 25. So this option is wrong and all these options are correct. 1, 2 and 3 are correct. See, question was very good. Even though examiner also thought that answer would be 25. If examiner would have asked you 25, then definitely option 4th were correct. Now next, in the next question we have a circular loop of radius 7 cm is placed in a uniform magnetic field of 0.2 Tesla directed perpendicular to the plane. If this is the plane, to perpendicular to the plane, okay, plane of loop, the loop is converted into a square in 0.5 seconds, in 0.5 seconds. So where is, so first of all we had a loop and that converted into square, okay. First, radius is 7 cm. If radius is 7 cm, area is what? Area is pi r square, okay. 22 by 7 is pi r square. (154 centimeter square). Okay. Now one more thing, its length would be what? Perimeter 2 pi r, 2 into 22 by 7 into r. Okay, r is what? 7. Cancel out 7. That is 22 to the 44 centimeter. So this should be also 44. So side of square would be what? 44 by 4, 11 centimeters. Okay. So its area would be what? Its area will be 11 into 11, 121 centimeter square. Now change in area. Delta A is what? How much? 154 minus 1 to 1, 3, 5 minus 2, 3, right? So yeah, 33 centimeter square. Now a circular loop of radius 7 centimeter is placed in magnetic field of 0.2 Tesla and that magnetic field is perpendicular to the plane of this circle or this square. The loop is converted into square loop in 0.5 second. This time is 0.5 second. Okay. Now the EMF induced. So you know EMF is what? EMF is minus d phi by dt. So phi is B. B is how much? Magnetic field is 0.2 Tesla constant. Area. So delta phi is what? B, that is constant, and area, delta area is 33 centimeter square, right? Centimeter square means 10 raised to minus 4, that is meter square. Delta phi by delta t, 0.5 second. So 0.2 into 33 into 10 raised to minus 4 upon delta t time, that is 0.5. Okay. Remove this point. Okay. So it would be 5, okay, into 10 into 10, 5 2s are 10, okay. So 2 2s are 4, 4 3s are 12, 132 into 10 raised to minus 5, right? So 132 into 10 raised to minus 5. Now in millivolt, this is what voltage. So 132 into 10 raised to minus 2, that is millivolt, and that means 1.32 millivolt. 1.32 millivolt, option number 2. Simple. Are yes or no? See, questions are really simple, but see, whenever you go for the exam next time, before marking the right answer, please recheck it, because that's not the waste of time. You are investing your time for good. If you are giving 15 more seconds, that means you are securing 5 marks plus 4 minus 1. You know the pattern. So now when an unpolarized light falls at a particular angle on a glass plate placed in air, okay, this is glass plate, and here this light strikes this, okay, then reflected beam is linearly polarized. Array, that means what? Array, that means this is Brewster angle. Yes or no? Brewster angle R. Okay. So that means what? Refracted beam with respect to the normal, tan inverse 1.52 is 57.7 degree. Refractive index of air and glass is 1 and 1.5. 1 and 1.52. And yeah, you know that tan IB. Tan IB is what? Tan IB is mu 2 by mu 1, 1.52 by 1, and if tan inverse IB would be what? Tan inverse 1.52, and that value is 57.7. So Brewster angle is 57.7 degree. We got this angle. We got the Brewster angle, that is 57.7 degree. Okay, this is also 57.7. okay, so this angle will be what? This angle will be, and if, okay, this is 90 and this is 57.7. So this would be what? 90 minus 57.7. 90 minus 57.7. So that would be 0.3 and 2 and 32.3. Yeah. So option number 3. Right? Simple calculations. Okay. So in question number 18, a small metallic sphere of diameter 2 mm and density 10.5 gram per centimeter cube is dropped in glycerine having viscosity 10 poise and density 1.5 gram per centimeter cube respectively. The terminal velocity attained by the sphere is. So terminal velocity formula is what? So you know the terminal velocity is 2 by 9 r square g by eta density minus density of object minus density of liquid, right? This is the correct formula. Are yes or no? Now you put the values and take the answer. Answer is in cm per second, and this poise is also in CGS unit. Everything is given in CGS, but this will be 0.2 centimeter. That's it. So now V terminal velocity 2 by 9, then R square. So R, radius is 0.2, 0.2 square. G, now G equals 10 meter per second. 10 meter per second means 1 meter is 100 centimeter. That means 1000 centimeter per second. Sorry, second square. So we need in CGS. So okay, not 10,000, only 1000. Because in 1 meter there are 100 centimeters. Simple. So 1000. Value of G is 1000 centimeter per second square. Then we have eta. Eta is 10 poise, right? And density. Now density is 10.5, object density. And where's the other density? Okay, density 1.5. So 10.5 minus 1.5, right? So we had value 9. So 10.5 minus 1.5. Can I cancel out this? Yes, because 10.5 minus 1.5 would be 9. 9 is cancelled out. Okay. Then we had 0.2 means 2 by 10. So 2 by 10 square means 2 by 10 into 2 by 10. So these two zeros will be cancelled out. 2 into 2 square and 2 by 10 into 2 by 10, 100 into 100. Okay. Now this is what? 2 to the 4 to the 8. So did we made any mistake, guys? Did we make any mistake? Oh, sorry. The mistake is diameter is given. Diameter is 0.2 centimeter, then radius is 0.1 only. Okay. So now instead of 0.2, this will be 0.1 and this will be square of 1. So only 2 centimeters will be the answer. Option number 2. Okay. 2 centimeter per second. Did you understand? Simple. Okay. Then next question is, suppose a long solenoid of 100 centimeter length. Now this is a lengthy question. We have a solenoid, length is 100 centimeters, radius is 2 centimeter. Okay, radius of solenoid 2 centimeter, length is 100 centimeter and having 500 turns per unit length. So N is N by L, 500 turns per centimeter, turns per centimeter. That means what? 50,000 turns per meter. Are yes or no? Per unit length carries a current I, where omega is, value of omega is 1000 radian per second. A circular conducting loop B of radius 1 centimeter coaxially slided through the solenoid. At the speed 1 centimeter per second. 1 centimeter per second. The RMS current through the loop when the coil B is inserted 10 centimeters. When you inserted 10 centimeter, okay, inside the solenoid is alpha by root 2 microampere. Alpha by root 2 microampere. Okay. So we need to get the value of alpha. and resistance of circuit, resistance is given 10 ohm. Wait, yeah, so first of all, magnetic field will be what? Mu naught Ni in solenoid. Yes, so let's take mu naught as mu naught, and that is 50,000, right? 50,000. And I current is given or not? Okay, let's say that is I current only, and I is 10 sin omega t. So that is mu naught into 50,000, then 10 sin omega t. Okay, that is B vector. In phi, in flux we need area vector as well. So area vector is how much? Area vector, radius is 2 centimeter. So area is pi r square. Okay, from there you will get B dot A. So B dot A, phi is B dot A. Now B is in the terms of sin omega t. So d phi by dt will be EMF, and that will be somewhere E naught cos omega t, and value of omega is 2000, not 1000 radian per second. Okay, now if you have the value of E, then you can find the current. Current is E by R. Are yes or no? And if you know the current, then RMS value is I by root 2. So that would be E by root 2 R. And if you know this value, then you know that would be equal to alpha. So we actually need E by R. Simple. This question is simple, nothing to do, but this is a lengthy equation and very lengthy calculation. Answer would be 197, and that is also a approx answer. You could get answer between 190 to 200 or 203. It depends on how you are putting the values. Okay, so don't get panic in the examination when you see these kind of questions. These questions are the time taking questions. Otherwise, in this question we did not do anything, everything was planned. B vector, by B vector we are going to calculate B and A phi, EMF d phi by dt, current E by R, and RMS current by root 2, and we need that value alpha by root 2. Okay, that answer would be 197. In question number 20, the ratio of speeds of electromagnetic waves in vacuum and in a medium. Let's talk about vacuum, medium. Vacuum and medium having dielectric constant K equals 3. Its dielectric constant is 3. Okay. Then permeability is 2 mu naught. Okay. So here if permittivity is epsilon naught, then here that would be 3 times 3 epsilon naught. Okay, and you know the speed of wave is 1 by root mu into epsilon. Okay, so initially we had in the vacuum. Now let's calculate for medium. In medium we have root 2 mu naught 3 epsilon naught equals 1 by root 6 1 by root mu naught epsilon naught. Okay, so C medium is C naught by root 6. What do we need? We need, okay, the ratio of speeds of electromagnetic wave in vacuum, C naught by Cm. C naught by Cm, so that would be root 6 by 1. Root 6 by 1, option 1. Easy, very easy. Option 1. In 21st question, suppose there is a uniform circular disk of mass m. There is a uniform circular disk of mass m, kg, and radius r, m shown in figure. The shaded region are cut out from. Okay, so m, capital M mass was initial mass, but now we have cut these two portions. Okay, the moment of inertia of the remainder about the axis A. Very simple. How? In this type of questions, first of all, you had these two circular rings. Now total radius is r, then its radius is r by 4. Are yes or no? And for a disk, mass is proportional to area. We know. So complete radius is 4 times of this radius. So if its mass is m, because mass is directly proportional to area, so complete mass will be what? Complete. If I am not talking about when we cut it out, I am talking about complete mass. So that complete mass would be 16 m, and capital M is 16 m. I hope you understood this step. Very easy step. I am saying if its mass is small m, then mass of the complete disk would be 16 m. Okay. Now we need moment of inertia. Okay, very simple. But if you cut it out, do one thing. You fill with m mass, m mass, m mass. Okay. Now again it is having capital M mass. So moment of inertia will be what? Capital M r square by 2. Okay. But while you are adding plus m mass, add minus m as well. Minus m mass as well. Then now parallel axis theorem. So this distance is how much? Basically I am talking about this distance. So this distance is, this is r by 4, 3r by 4. Okay. So minus, I am calculating for minus mass. So those are two masses, equal masses, twice. Okay. Twice of now ml square. M L is 3 3 is 9 r square by 16 plus ml square plus its inertia, moment of inertia. That moment of inertia is mr square by 2, mr square, but its r is r by 4. So r square by 4 4 is 16 into 2, right? mr square by 16. Now what we are going to do here, that would be m small r square by 2 into, okay, minus, and 2 by, let's take 16 common. If you are taking 16 common, here we have 9 mr square plus mr square by 2. Okay, so 2 8 ja. Then we have mr square by 2 minus, see, mr square by 2 minus 1 by 8. 1 by 8, 9 mr square plus 1 by 2. So 9 2 ja 18 plus 1 19. 19 by 2 mr square, right? Okay. So 9 by 19 by 2, and this is 8 to the 16, or you cancel out this. Arey, why we are cancelling it out? Okay, now I'm going to do one thing. M equals M by 16. Put that value, you will get your answer. Okay, let's do that. So total I is mr square by 2 minus 19 by 8 to the 16. 19 by 16, and m would be what? M by 16. M by 16, okay, r square. From here, if you take common, so what will be the, okay, do calculations. Okay, did you do the calculations? When you put value m by 16, then what comes? 16. Let's do it. So that would be 16 into 8 mr square minus 19 mr square upon square of 16, right? So square of 16 is how much? So square of 16 is, could you do the square of 16? 256. Yeah, square of 16 is 256, and 16 at the 128 minus 19. Okay, so that comes, okay, 128, so 109. 109 by 256 mr square, right? So that's the answer. Question is asking h by 256 mr square. So value of h is 109. That's the answer. Okay. See, calculations are difficult, otherwise concepts are very easy in the questions. The size of the image of an object formed by a thin lens are equal when the object is placed at two different positions. Okay, let's say here the lens, and u1 at 8 centimeter, u2 24 centimeter. Okay, formed by a thin lens, images of an object. If the size of the image of an object when the object is placed at two different positions, 8 centimeter, 24 centimeter from the lens, the focal length. Okay, so if same size, then focal length is u1 plus u2 by 2, right? So 24 plus 8 by 2, so 16 centimeter. Its focal length is 16 centimeter. Otherwise you could find by the formula as well, because V will be the same and you will get this relation only. So directly use the relation if you know the relation. Okay. Then question number 23. In question number 23, the velocity of sound in air is doubled when the temperature is raised from 0 degree centigrade to alpha degree centigrade. 0 degree means 273 Kelvin, 2T Kelvin, and we know speed of sound is proportional to root T. Now when the velocity of sound in air is doubled, if speed is doubled, if this is doubled, then temperature, so temperature is proportional to V square. Temperature is 4 times of initial temperature, so this would be 4 into 273 Kelvin. So 4 3s are 12, right? 4 3s are 12, 28 plus 1, 29 to 4 to the 8, 9, 992 Kelvin. Okay, this is what Kelvin. In degree Celsius, what will be the answer? So answer would be 992. Okay, is it okay? Yeah, I guess this is okay. Or once again let's do it. No, this is not okay. 4 3s are 12, 1, okay. Then 4 7s are 28, 28 plus 1, 9, 2, 4 2s are 8 plus 2, 10, 1092 Kelvin, sorry. This is 102, okay, 10, then 92 Kelvin. So answer would be 1092 minus 273. So here we have, so 9 and 1 8, 819, okay, 819 degrees Celsius. Simple, because velocity of sound is proportional to root T. Next is the average energy released per fission for the nuclei. This nuclei is 190 mega electron volt. When all the atoms of 47 gram, so number of moles will be what? 235 upon 47. So number of moles is okay, sorry. Number of moles 47 upon 235, so 1 by 5 mole, okay. These are number of moles, and in n moles, in 1 mole, how many nucleus are there? Number of nuclei is equal to Avogadro number, 6 into 10 raised to 23 per mole, okay. In 1 by 5 mole, in 1 by 5 moles, that would be 6 by 5 into 10 raised to 23, okay. Yeah, and each fission gives 190 mega electron volt. So these much nuclei are going to do fission. So total energy will be these much nuclei, 6 by 5 into 10 raised to 23, and energy for per fission 190, okay. Now 5 3s are 15, right? 228, right? 228 into 10 raised to 23 mega electron volt. So 228, alpha is 228. Yeah, correct. Question is easy. In question is saying that per fission we are getting 190 mega electron volt energy, okay. Now total number of moles 1 by 5. In 1 mole we have these much nucleus, okay. In 1 by 5 moles, these much nucleus. These all are going to do fission. So total energy will be multiplication of this into 190. So that would be 228 into 10 raised to 23 mega electron volt. Alpha is 228. Okay. So now this is the last question. A ball of radius r and density rho. A ball of r and density rho. Density rho dropped through a viscous liquid of density sigma and viscosity eta attains its terminal velocity at time t. So we are going to do integration to find that time t, because there will be a time when it will get a terminal velocity, because initially it has acceleration, but the viscous force is increasing with the velocity, and at a time viscous force will adjust that velocity and that force, so acceleration would be 0. Okay, so the time is given by this formula. A rho A RB eta C and sigma D. Okay, simple. Where A is constant and A, B, C, D are integers. If this is constant, okay, so we could do it by dimensional equation. Dimensional equation for time is T. So in RHS also we should have T. This is what density. Density means m by L cube, right? And it has A. R means L. L B. Eta. So eta m L minus 1 T minus 1, right? M L minus 1 T minus 1. It has power C. And this is also density m by L cube and power D. Now see m. So m power A from here plus C plus D. Okay, so A plus C plus D should be 0. Are yes or no? So could I say, wait, okay, could I say that A plus C plus D is 0. Now L minus 3A plus B minus C minus 3D. Okay, this should be also 0. M, L, then T. Now in this term we don't have T, no, only here. So T is how much? T minus C. So minus C is 1. Minus C is 1. That means C is minus 1. First of all we got the value of C. Then put that value here. A plus C plus D should be 0. That means A plus D should be 1. Because C is minus 1. So A plus D is plus 1. Put these values here. Minus 3A plus B minus 3A plus B minus C. Okay. That is D, not B. Minus 3AD, B minus C plus B minus C. This should be 0 and A plus D is 1. So minus 3 and C is minus 1. Minus B minus plus 1, 0. So B should be 2. If you got the value B, C, okay, simple. B plus C, B is 2. 2, C is minus 1 upon A plus D. A plus D is also 1. So 1 by 1. Answer is 1. Answer is 1. Understood? Okay. So answer is 1. And thank you so much guys for joining us at Infinity Learn by Sri Chaitanya.